On problem number 24, they're going to ask us either about parallel or perpendicular lines. And so we should do both types. And so the thing to deal with, or what to do with parallel or perpendicular, is to find the slope. And so that's what they're asking for here, actually, is find the perpendicular slope. So in order to find the slope, we need to solve for y. So that's what I'm going to do first. I'm going to move this 3x to the other side. And when I do that, I'm left with 5y equals negative 3x plus 2. And so then I just have one step, and that's to divide by 5. And really, we have to divide every number by 5, but all we really care about is the slope of this line. And that's what we get here, negative 3/5 x, and then plus 2 over 5. So the slope is this negative 3/5. This is what we're concerned with, but we want the perpendicular slope. So the perpendicular slope is opposite and reciprocal. So the opposite sign makes it a positive, and the reciprocal makes it 5/3. And so that's what we end up getting there. 5/3 is the perpendicular slope, because the slope here was negative 3 over 5. Well, let's take a look at this one. Same sort of thing when they're finding out whether we're going to have to find the parallel slope. Well, first we need to find the slope of the line that we're given. So we're going to subtract the 2x from all sides. We're left with this negative 5y equals negative 2x plus 6. So we've got one step of dividing by negative 5 this time. That's going to switch all the signs there. So what we're left with is a y equals, and then we have positive 2/5 x minus 6 over 5. So all we are concerned with is the slope. And so that's this number right here, this 2 over 5. And so that's the slope of this line. Well, parallel slope is exactly the same. So it's the same exact slope, 2/5. So that's the difference. Parallel is the same slope, perpendicular, opposite, and reciprocal. So again, all you're going to do is get y by itself. So you're going to have to do that on your test. And once we do that, we got negative 4y equals negative 3x plus 1. So all you're going to do is divide by the negative 4. That'll get the y by itself. So we're left with y equals 3/4 x minus 1/4. So all we are concerned with is the slope. So that's what we're mining for here. So we got it. 3/4 is the slope, but we want the perpendicular slope. So that's opposite sign, so it's going to be negative 4/3. That is our answer. The last one's a parallel one. So we're going to go ahead and subtract that 5x from all sides. So now we've got 6y equals negative 5x minus 2. So we just have the one step of dividing by 6 on both sides. So divide by 6. So what we now have is this y equals negative 5/6 x minus 2/6. You can reduce that to 1/2 if you want, but it's not really necessary because what we are concerned with is the slope. The slope of this line is negative 5/6, and we want the parallel slope. Parallel slope is the same. So our answer is negative 5/6. Well, that's question 24, 25, and 26 are solving systems of equations. So there's two methods that we're going to end up using when we're solving these systems, and one is substitution. So whenever you have y by itself, substitute that expression that y is into the other equation. So y or x by itself, substitution is the best method. So now we have 2x plus x plus 3 equals 6. And so we go ahead and collect some like terms. We got these two terms here we can combine. Makes 3x plus 3 equals 6. And so we just go ahead and start moving some terms around. Subtract that 3 from all sides. So now we've got 3x equals 3. And then you just divide by 3. That'll get your x all by itself. So x is 1. So once we've got that, substitute that value back in for x, maybe that top equation there. Y equals 1 plus 3, so it makes 4. So there it is, 1 comma 4. So the answer is an ordered pair. It's where the two lines end up crossing. Taking a look at the next one, we've got a problem where x's and y's are lined up. This is a great one for elimination. I'm going to multiply this bottom equation here by 2. So every number there gets multiplied by 2. So I now have negative 2x, a positive 6y, equals a negative 24. And so I'm going to bring this other equation down, and so it's just 2x plus y equals 3. So when I add this stuff together, you see the x's cancel. I'm left with 7y equals, and this makes a 26. So let me check my work there, make sure I set things up right, because I'm getting a number that's not quite going in there evenly. And my number would be negative, so let me check my work. So I've got the 3 brought down, I brought down the y, the 2x. This makes a negative 2x. Got the 6y, and oh, that's 24. So caught my error right there. So that's 24, not 29. So when I do subtract those two numbers, fix that, that'll end up being 21. So let's make that negative 21. And so we divide by 7 now, and I have y equals negative 3. And if I found that I didn't see an error, then I'd go with the numbers. But once I saw that they weren't turning out as cleanly as I thought, maybe I made an error. So I took a look, and I sure did. So we substitute that negative 3 back in for y. We've got 2x, and then a minus 3 equals 3. So we end up having to add 3 to both sides. And when I do that now, I've got 2x equals 6. And so I can go ahead and divide by 2 on both sides, and that'll give me my value of 3. So x equals 3. So we've got a ordered pair here of 3, negative 3. Take a look at the next one. We've got a problem where we've got y by itself. So this is a great substitution problem. Now, sometimes you have x by itself, and that's what you'd put that expression in for x. But here we got y by itself again, so we'll put that expression in for y. Now we've got 3x minus 3x plus 2 equals 6. Well, when we go ahead and combine, we see something strange happening. The x's are all canceling, so we got 2 equals 6. So what this means is we have parallel lines. And parallel lines don't cross. And so that means we have no solution, because what we're looking for is where the two lines cross. That's what the answers here represent. But when we have two numbers that don't equal, no variables left over, we've got a no solution. So we've got parallel lines. Oh, it's another problem where we get to use substitution. So we can go ahead and put that expression in for y. So we got 2x minus 2x plus 3 equals 3. Well, we get the same situation where the x's end up canceling, but this time we get the two numbers equaling. So what this means is that we have the same line. And so that means every point on the line is a solution. So we say there are infinitely many solutions. So there's so many we can't even count them. So that would be our answer. Well, looking at the next type, it's question number 27 on the test. I would end up graphing both of these lines, and what I'm going to end up doing with this one is I'm going to go ahead and solve for y. So I'm going to move this 6x over to the other side, so it becomes 2y is greater than or equal to negative 6x, and then a minus 2. So basically what I did is I subtracted that 6x, so that's why it's minus 6x here. Now I'm dividing by 2, so I end up with y is greater than or equal to negative 3x and a minus 1. So that's going to be easier to graph. So I'll start with this first one here. Plus 4 is the y-intercept, so up 4, 1, 2, 3, 4. Put the dot there, and then use the slope. It's 2 to 1, so up 2 over 1, or down 2, 1 to the left, and it's a dashed line. And then we go ahead and shade. It's y is greater, so that means you're going to end up shading above. So I'm just going to put some arrows above. That'll remind me that's the direction I need to shade. Take a look at the next line. Negative 1 is the y-intercept, so we're starting down 1 space. Negative 3 is the slope, down 3 over 1 to the right, or up 3, 1 to the left. This time it's a solid line, and it's a positive y greater than or equal to. Greater means towards the bigger y values, so it goes up in that direction. So you look to see where they compare or where they agree, and the only region is right in here. Well, let's look at the next one. Same sort of thing. We'll start with this equation. Y is greater than 4x minus 1. So go down 1 and go up 4. 1, 2, 3, 4, and over 1 to the right. Or down 4 and 1 to the left. And then we draw the line. It's a dash line. And this time we're going to end up shading greater, so above. So above this line, towards the bigger y values. And then taking a look at the next equation, this one you could end up using xy intercepts for. See, 2x and 6, that makes an easy number to deal with. X would end up being 2x, I'll say, less than 6. So x is going to be less than 3. So over 3 spaces. So I'll go over 1, 2, 3, put the dot there, and then I'll do the next one. So 3y less than or equal to 6. So y is less than or equal to 2. So go up 2, and then draw the line. This one's a solid line, has a line underneath it. So I'll draw that solid line, and then read what it says. Well, here we could read either one. X is less than 3, so smaller values for the x are in this direction. Or y is less than 2. Well, that means down this way, so it's the same direction. So you could have read either one of those and got the same answer. So to figure out where you shade, you look to see where the arrows agree, and that's right in this region here. Well, looking at the next one, we've got ourselves an x, no y. So if it's just x, that means all the values for the ordered pairs are at x at -3. So go over 3 spaces to the left, and that means that it's a vertical line. It looks like this. It's equal to, so draw that solid line right through those, and they should be right on this black line here. So it's in this direction here. So just darken my line since I've already messed it up enough there. So it goes in that direction just like that. Now, it's a x is greater than, so it's going off in this direction. That's the direction that you'd end up shading. So let's take a look at the next one. It says, well, 4x, 2y less than 2, so I'm going to go ahead and solve for y. So I've got 2y less than -4x plus 2. So if you move something to the other side, notice it switches signs because I had to do an opposite operation. I'll divide both sides by 2. I've got y is less than -2x plus 1. So I go up 1 space, draw the dot there, and then go down 2 to the right 1, or up 2 left 1. And then draw that line. So it's a dashed line. And I end up shading y less, so less means below the line, so it's in this direction. So the region it would shade would be right in here, where the two lines agree. Well, those are up through 27. Check out other parts for further problems.